Hello class, welcome back to Statistics and Mathematics YouTube channel. My name once again is Ernest Sechim. I'm a teaching and research assistant at Kwame Nkrumah University of Science and Technology. Please, if you haven't subscribed, kindly subscribe, like and share so that these videos too can get to your friends and they too can benefit from the video. So today, our main focus is to learn about arithmetic in R. Right, in the last video we learned about how one can download and install R. So please, if you haven't watched that video, or if you don't have the software already on your machine, kindly go to our last video or our previous video and then watch and learn how you can download it on your respective computers. So for arithmetic, we learn arithmetic in our primary schools, and then we learn that for the arithmetic we have addition, subtraction, multiplication, division, and what, etc. So here we are come to use R to be able to add numbers, subtract, multiply, and what, divide what, numbers, right? So we are going to use R to do all these kind of stuff, right? So in our last video I taught you guys how one can run codes, right? If you already have codes in R, I told you how one can run that code. But before we start, you see we have some symbols here, right? So you have this one and then what, equal to, right? A lot of what equal to's, what punch in R, right? I use this symbol and the equal to because I just want to make my code understandable. Because if you pick this code, you can see that there is addition here. So if more or less you run this one, right, and then you see some total, you say, oh, this one there we are adding, right? So we use all these kind of stuff to make our code very beautiful and presentable, right? So that once one gets your code, one can understand what you have written inside, right? So here our first on the list is what, addition, right? We want to add numbers in R. So if you really want to add numbers in R, for instance, if you have this 10 plus 5 plus 50 plus 34, want to add it in R, you just type a 10 plus 5 times plus 50 plus what, 34, right? So once typing, just put your cursor here and then run. Once you run, you can see that there is what, addition, the number what will come, and the total answer for that number that you want to add to will come here, right? So 10 plus 5 is what, 15. 15 plus 50 is 65, and then 65 plus what, 34 is what, 99. So as you can see, so R has added nicely for us, right? So next on the list here is what, subtraction, right? You want to subtract what, two numbers. When you come to R2, one can subtract what, two numbers in R. So here we have 10 minus what, 5, right? So just point it as you are typing. Just type as you are typing. It's like 10, right? Sorry, like here when you come here, you have 10 minus what, 5, right? So once you write, you type 10 minus 5, then you execute, just run. Once you run, you see that 10 minus 5 is what, 5, right? So we just use the addition symbol and the subtraction symbol in R to add and subtract, right? And for the multiplication, to use the star. The star will help us to multiply two things in R. So here we have 12 times what, 45. So the 12 times 45, as you can see here, once you point this one in R, R is going to do the calculation for you. So let's run. Let's run it nicely. Once you run, you are going to get 540, right? So R has run it for us, has multiplied 12 by what, 45, right? And then next on our list is what, division, right? Division. So for division, we are just going to divide two stuffs, right? So here we want to divide 34 by what, 78, right? So if you want to divide 34 by 78, we just use what, our backspace was sign, right? So we just use what, this sign, and then just use to divide these two numbers, right? So once you run, I'm going to get 0.358974, right? So this is how you do division in R. And then exponentiation, right? For instance, if you have been given a number and the number is raised to a certain power, right, you have come to learn how you can multiply this thing to also in what, in R. So for instance, if you have 10 raised to the power 3, we have 10 raised to the power 3 here. It's just 10 times 10 times 10, right? But if you want to write this exponent, right, we use what, this sign. So you write the base and use this sign, and then write what? Your exponent, right? So here, this is going to give us what? An answer of what? 1000, right? Because you have 10 times 10 times 10, which is what? 1000. And then we also have 90 square root 90 raised to the power 2, right? So once you 90 raised to the power 2 and run, you're also going to get 8,100, right? So when we were also in senior high school and basic school, we came across what we call board mass, right? We are going to apply the same idea that we use in board mass, right? But for you to, for the purpose of this class, we are going to use what we call the PEMDAS, right? As you can see here, PEMDAS, right? This is the PEMDAS, right? So for the PEMDAS, the P represent what? Parenthesis, right? And then the E represent what? Exponentiation, right? And the M represent what? Multiplication. The D represent what? Division. And then A represent addition and what? Addition, and then our X represent what? Subtraction, right? So at the end of the day, if you have this like 2 plus 3 times 5 raised to the power 2 and want to execute, right? Yes, even if you don't have any parentheses, I will do it according to order of what the PEMDAS, right? So once you run this one nicely like this, you are going to get what? 77, right? And then also we have this one, bracket open, 2 plus 3 times 5, all raised to the power 2, right? So at the end of the day, I'm going to punch this plus this one is going to be 5. 5 plus 5 times 5 is 25. Square root of what? Square of what? 2. We're also going to give us a nice answer, right? So when you run that, we are going to get 625, right? So that's how we can also use the PEMDAS to solve a lot, right? And the next on our list is to maybe use how we can use modulo arithmetics, right, in R. So for you to be able to use modulo arithmetics in R, we use what we call the double dollar sign. The double dollar sign will help us to do our modulo in R. So here we have our 100. We want 100 in mode 75. If we want 100 in mode 75, that's what the remainders of our 75, right? So I don't believe once you run, we are going to get our answer nicely. That's 25. As I said, it's just the remainders of what? 100, right? And then next on our list is how we can use the natural log, how we can use the exponential function, how we can use the square root in R. So for one to be able to use the natural log, one has to just write log into bracket of what? The number that you want to turn to that natural log, right? So here we have 3.7857, right? That's the number that we want to find the natural log on, right? So once you put it inside this, then run, right? If you run, you are going to get our answer as what? 1.331231, right? And then the exponent, right, raised to what? A power of what? 8 argument, right? So at the end of the day, you will see that we have ASP bracket open 10, right? Just going to give us the number of times that base is just repeating itself. For example, if you have 10 raised to the power 5, we are going to have 10 times 10 times 10 times 10 times 10, right? So I don't know, that's how things works for that one, right? And then let's come to the square root, right? So for the square root, we are just going to return the root of what? 8 argument. For instance, if you want to find square root of what? 49. If you don't want to find square root of 81, right? You can use our function called SQRT function to find that one. So let's execute this one for you guys to see. Once you run, you are going to get 7, and the 81. Once you run, you are going to get what? 9, right? And then next on our list is what? The absolute. Sometimes you have absolute value. You have to change it from its negative to what? The positive one state, right? So at the end of the day, right, we use what we call the APS, right? Argument to return the absolute value of what? The argument, right? So here we have absolute of what? Negative 10. Absolute of negative 10 is 10. Since we are just for absolute, if it is negative, it becomes positive, right? So we just run. You see that we have 10 here, and then just run this one too. We just have what? 20, right? So all that we are trying to say is that for the ABS, right, it's just an absolute, and if it is negative, everything will come back to what positive. And then the pi returns the constant pi, right? So at the end of the day, you just hit pi, right? So once you hit pi, you have our standard value, that's 3.14159, right? And then that's how this two behaves. That's how this two behaves. And then let's jump into what running of what numbers, right? For instance, a big data is being given to you, right? And they want you to run a certain column into this respective what decimal places, right? So we use this one to we find out. So what we use is that we use what we call the run function to be able to change decimals into a whole number, and also to change a whole number into what decimals, right? A whole number, you can also use that one to change a whole number into what decimals, right? We can do that by adding 0.00000, right? Can also be changed to what decimal, right? So let's use the run function, right? So for the run function, we just put in our argument 233.234, right? So we didn't substitute any digit that is going to run it to the nearest place. So once you just put your digit inside the run function like this, it's just going to turn what a whole number, right? So here you have 233, right? 233, right? But for this one, we just want to run it to at least 3 decimal place, right? So 233.2344567, right? So I just run it to 3 decimal place, and I just run. We are getting 233.234, right? Just 3 decimal place, right? So we have two things that we have to also take note of. We have what we call the floor, and we have what we call the ceiling. So those who have done economics before, I think you guys have come through this before. You guys have come to this one before. So for this one, the floor is used to run number one down, right? And then the ceiling is used to run number up, right? So here you have 2.23, right? So here, since you are going to write it since you are going to run it down, it means that we are going to remove all the one. We are just going to make the number before the decimal place what a constant, right? Always, that's how it will be. But for the ceiling, you have to add 1 to this, no matter what, right? Even if here is 0.00001, right? Once you use the ceiling, this you have to add 1 to the 2 to 3 to get what 3. So at the end of the day, this is the end of what arithmetic what class. Can you take your time, go through, so that at the end of the day you will be blessed and relieved from what your stress. Thank you for joining the class. Bye.